Hello, everybody. I will start my today another live coding session. So today I solve this question: subset. Given an integer array nums of a unique element, return all possible subset. The power set. The solution set must not contain duplicate subset. Return the solution in any order. A subset of an array is a collection of elements possibly known of the array. Okay, so including an empty array. And this is a subset, not a sub. I mean, this is a set, so order doesn't matter. So if I put 1, 3, I don't include 3, 1. Yeah. Returns the solution in any order. Okay. So let me clarify my understanding on this question first. So I'm given as the interface, I'm given the integer array nums. And I will return all possible subset, which should be to the array. To the int array. Yep. Okay. Aside from that, I will check some constraint. For example, given array nums, could it be empty or not? So I will take a look at the constraint and I find that it should be at least one element. Okay. Good. So that being said, let me think of this question with some examples. Yeah. Oh, by the way, I quickly note that, for example, if I'm given 1, I have to return empty array and 1. I mean, don't forget empty array. I just noted it. Okay. That being said, let's say I'm given this. In that case, so what I will return is 2, 3, 1, and also 1, 2, 1, 2, 3. Yeah, every possible subset and empty array. Yeah. Oh, by the way, all the numbers are unique. Yeah, which means that, I should say, when I start from here, when I decided I include this one, I will try this and also this, but also I have to take care that there is a case that I skip this 2, but I clone this 3 and 4. Yeah. So I think the brute force approach is that I think I can use the kind of recursion. Firstly, I will decide I include this 1 or not. If I include it, I put 1 here. Then I take a look at 2, 3, 4, and maybe I will include 2, but maybe not. Then when I take a look at 3, I include it or maybe not. In this way. So in this way, it will take. Oh, by the way, I keep track of the numbers I've chosen so far, and I append the next number if I choose it. Then in the end, after I traversing all the numbers, I build the array, and add it to the return that list. Yeah. Then return it in the end. So this is obviously the backtracking. So the time complexity should be so this is the recursion method interface I will implement. So every time I take a look at this nums I and include it or not. Yeah. For each of these cases, I append this number to the returned, nums solver array. Then I keep going until base case, which is I is equal to given nums, which means that the traversal is ended. So that being said, the time complexity should be, first I can say, I have to call this find num 2 to the power of n times, assuming that there are n element in the nums array. And for each, it takes only the constant time, aside from another recursive function call. Yeah. This 2 to the n comes from because firstly, I have two choices for the first element, and there are two cases. I choose it or not. I include it or not. Then for the second one, for each of these cases, I have two choices. Include the second one or not including the second one. So in that way, in total, it should be to the power of n. So this is the time complexity. For space complexity, I need num solver, which could be up to O of n in the end of the, when I is equal to length nums, it should be exactly n element. And also, I need the recursion stack, which means that this find num recursive function, the depth, max depth should be n, because every time I choose a new number, I go to the new index. There is, one more recursion stack is added. So when I reach the final index, it should be n recursion stack. So in total, this should be O of n. Okay. That being said, I start the implementation. Oh, and I can say, I think this is the best achievable time complexity. Yeah. Because at least I have to build the array. Oh, no. I have something I forgot to say. So in the end, what I have to do is append to read. This takes more time because I have to copy this num solver array when I'm adding this to the returned array, because num solver array will be mutated later, which means that every time I reach the end of the in the last index, there should be 2 to the power n times. I have to copy the whole num solver I've chosen, which is up to n, and append it to the num solver, returned array. So time complexity should be 2 to the power of n times n. And I'm pretty sure this is the best achievable time complexity because when I take a rook as the input, there are 2 to the power of n elements, and each of them is up to length n. If I just try to create this return array, it still takes 2 to the power of n times n, which means that this is the best. Okay, so let me quickly start the implementation. So okay, here, as I said, the base case is so let me make it shed variable. In this case, I've built C. I will build it. So okay. This is a base case. Otherwise, I have 2 options. I choose included or not. Then I keep going. Yep. And I have to roll back after coming back. In that case, I just have to call self.find. Okay. Yeah, I think this is it. So now let me try run my code. Let me start with this case. So my biggest concern is if an empty array is included in the returned list. In this case, so self.nums is now 1 only, and I call self.find with index 0, and I go to line 56. 0 is equal to length nums, which is 1. No. Yeah, no, not yet. So this is not true yet. So I go to line 61, and I have 2 cases, included or not. In line 61, so I append self.nums index 0, which is 1, to nums solver. Then I call self.find with I plus 1, which is 1. Then what happens is that when I call this with index 1, in line 61, 1 is equal to length of self.nums, which is 1. So I go to line 62, and self.found append, self.numSoftware.copy, which is list 1, and I return, come back, and that's it. And I come back to line 66, line 67, and I go to line 68. And I pop element 1 out from numSoftware, and I go to line 71. This time I call self.find with I plus 1 again. So self.find 1 is called. So in line 61, again, 1 is equal to 1. This is the base case. So I go to line 62, and I append numSoftware.copy, which is an empty list. Good, and that's it. I come back to line 71, and that's the end of the find, 0. I come back to line 57, and I return self.found, which is list of list. Okay, this is completely as expected. So I passed this test case. To be honest, at this moment, I'm pretty confident. At least I could cover all the lines in my implementation. So yeah, obviously I should have tested. I should test something like this. But yeah, let me submit my code because I'm pretty confident with that and to save my time. Okay, accepted. Good. Okay, so let me quickly wrap up. So today I solved the question subset. So this is a question in which I'm giving one integer array nums of a unique element. So this unique is important because I don't have to take care of the duplicate element in the returned list. So yeah, I'm given the integer array nums and return all possible subset. So for this question, I use the backtracking. Yep. For every index, I had 2 choices to include it or not. And based on that decision, I keep, solving the question recursively. And in the end, when I traverse all the n elements, I append the result to the to the return list. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.